Hello everyone, welcome to the third lecture of University Prep Calculus. In this lecture, we'll learn about few more graphs and we'll learn about odd and even functions and we'll learn about increasing and decreasing functions. So let's get started with the graphs. So we see we have four graphs. The first one is from -2 to 0 and the second one is 2 to 4, 0 to 2. The third one is 2 to 4 and last one is 4 to infinity. So we have four graphs given. We'll try to find the equation. So we know the first one is a straight line and we know from y equal to mx plus b we can find the slope delta y over delta x, and the slope is going to be 1 and the y-intercept is at +2. So the first function is x plus 2. Same, the second will be a negative function, negative slope, so it's going to be negative x plus 2 because y-intercept is 2. And the third one is just a line, is 2. And last one is a hyperbola shifted 4 units to the right. We'll learn about shifting in later lectures. And just to give you a reminder, if you see uh, root x minus 4 and the domain is x is greater than 4, that means 4 is not included in the domain because it's in the domain, and also from the graph we know because it's an open circle there. For line 2 we can see 2 is not included in the domain because it's an open circle. 4 is included in the domain because it's a closed circle, and to represent it, 2x is greater than 2 or less than or equal to 4. So that was already covered in previous lectures, and now we'll learn about odd function and even function. So what is even function? When f of negative x is equal to f of x, it's a even function and the function will be symmetric in the y-axis. What is odd function? When f of negative x is equal to negative fx, and then it's a odd function and the function will be symmetric in the origin. So two different, for even symmetric in the y-axis and for odd symmetric in the origin. We can also prove it algebraically. So let's look into the example. Y equal to x squared. Is it an even function? Yes, because it's symmetric around the y-axis, and also we'll prove f of negative x is f of x. So what that tells you, even we substitute x with negative x, the function doesn't change, it remains as the original function in the even function. And even function means when you have a degree of 2, 4, 6, those are even degrees. And in even degrees we know, even you multiply even degree, even if you have a negative, it's always gonna be positive because negative is positive. And let's try to prove it. The original function was x squared, and then we substitute that with negative x, and then negative x squared is equal to x squared again. So we can say f of negative x is equal to f negative x, f of x, and that's an even function. Now let's look at the second example. 5x minus x to the power 3. Is it an odd function? Yes, because it's symmetric to the origin. It is an odd function, and to prove it algebraically, we substitute f of x with f negative x, and we find f 5 times negative x minus negative x to the minus negative x to the power 3, and at the end we get negative 5x plus x3, and if we factor out the negative we get negative 5x minus x to the power 3. So the rule for odd function, f of negative x is gonna be negative f of x. So the original f of x was 5x minus 3, 5x minus x to the power 3. So f negative x is gonna be, we have to multiply the whole function by -1, so it's also going to be negative 5x minus x to the power 3, and we substitute f of negative x, we get the same value, so which tells it's an odd function. Now we'll go into decreasing and increasing function. If function is increasing if x1 is less than x2, and increasing decreasing if it is x1 is greater than x2. So we'll look into few of the examples here. The first example is a parabola. So if we look from negative infinity to 0, is decreasing because x1 is greater than x2. If we look into the increasing side of it, 0 to infinity is increasing because x1 is less than s2. The second one is a odd function, and it's always increasing. So it's increasing from negative infinity to positive infinity, because for this x1 is always less than x2. The last one is hyperbola f is equal to root x, and it's increasing from 0 to positive infinity. So yeah, that will be all for today. If you have any question, you can simply put a message on it. I will try to solve more questions, and don't forget to subscribe my channel. Thank you very much.